Here we're told in triangle ABC, A is equal to 9 units, B is equal to 12 units, and angle A is equal to 135 degrees. Solve the triangle. So here I can see that if I draw out angle A, and then if I draw out side C and the known side B, which is equal to 12, and angle A here is obtuse, it's 135 degrees. Well, really the only, one of the unknowns here is angle C. And so if I rotate side A, which is known, and I go through all the possible values of angle C, given that I don't know what angle C is, I can see that no matter what angle C is, that A will never, if A is 9 units, it'll never intersect side C. So what that means is that there's no possible triangles in this case. There's no triangle such that a side that's opposite of an obtuse angle is shorter than another side. Okay? So if A is obtuse and side A is less than side B, then no such triangle exists. That's really important. And let's see what happens when I try to use the sine law to solve this side-side angle case. So if I try to use the sine law to solve for angle B, let's see what happens. So I have that sine of angle B over 12 is equal to the sine, no, that's correct, is equal to the sine of 135 degrees over A, which is 9 units. And so sine B is equal to 12 sine 135 degrees. I'll divide it by 9. And so sine of B, well, this actually simplifies to 12 over 9 simplifies to 4/3. And sine of 135 is root 2 over 2. So this would be 2 root 2 over 3. This would simplify to 2 root 2 over 3. I can figure out what angle B is. Angle B, if I take the arc sine of both sides, or if I take the inverse sine of both sides, I get that angle B is root 2 times 2 divided by 3 is 70.5 degrees. So my calculator told me that angle B is 70.5 degrees. And of course this is approximation, so maybe I should have written that out. So angle B is approximately 70.5 degrees. And if I trusted my calculator, something's wrong, because we know that the angles in a triangle should add to the interior angles in a triangle, that is, should add to 180 degrees. But angle A and angle B add up to an angle that is, so angle A plus angle B is equivalent to 205.5 degrees. And that's impossible, because I have this other angle, angle C, and the sum of the three angles should give me an angle that's exactly 180 degrees. So this is impossible. So that's another justification that no such triangle exists. I've already mentioned here that if A is obtuse and A is less than B, or side A is less than side B, no such triangle exists. So there's no point to really restating this, but I could just say that angle A plus angle B plus angle C has to be 180 degrees, and yet angle A and angle B, or angle A plus angle B, is greater than 180 degrees. Therefore, no triangle exists. So that's just one more piece of evidence that that this triangle is impossible, or no such triangle exists. I should have said, whatever. No triangle exists with these parameters. Okay, I should have said really no such triangle exists, but that's okay. Okay, so in example 6, we're told in triangle ABC, A is equal to 15 units, B is equal to 12, and angle A is equal to 135 degrees. And in this case, you can clearly see that side A is 15 degrees. Side B is 12 degrees. So we have that side A is greater than side B. And we can see that if we draw this out and then we rotate side A about the pivot point at or about the vertex C, then we only get one possible triangle where side A intersects side C, and that's this triangle here. There's only one possible triangle. So in this case, we have that side A. Let's just say, if in the side angle case, if angle A is obtuse and side A is greater than side B, then one such triangle exists. Then one such triangle exists. And then we can solve this triangle. And if you solve it using the sine law or the cosine law, which you can do in this case, by the way, you could solve for side C using the cosine law. You'll see that there's only one possible triangle that exists. And you will find that you won't get a case where you get angle A and angle B adding to a value that's greater than 180 degrees. So let's just go ahead and do that. Let's just say, okay, I know that sine of angle B over B is equal to sine of angle A over A, and I know that sine B in this case is going to be equal to, or sine B over 12 is going to be equal to sine of 135 degrees over 15 units, or over side length 15. So sine B is equal to 12 sine 135. Oops, 135 degrees over 15. So angle B is equal to the arc sine of all this, which is 12 sine 135 divided by 15 is equal to 34.4 degrees. And here again, I've approximated this value. I've rounded it, so actually my calculator uses an algorithm that actually rounds this value. So that's why it's okay for me to use the approximate symbol. Okay, so angle B is approximately 34.4 degrees. That means that angle C is equal to 180 degrees minus 34.4 degrees minus 135 degrees, which is equal to 180 minus 134.4 minus 135 should give you 180 minus 34.4 minus 135 is 10.6 degrees. Okay, so angle C is equal to 10.6 degrees. Okay, so the last thing that we have to figure out is the reason that I'm solving for angle C and angle B, even though I already know that one such triangle exists and I know what angle B is because I'm told to solve the triangle. Anytime you're told to in a question to solve the triangle, it means to solve for all of the unknown sides and angles. So I've got angle B, I've got angle C, and now I just need to know what side C is. So side C, I can solve for using the sine law again. I know that C over sine C is equal to A over the sine of A. And sine of C is sine of 10.6 degrees. A is 15, and the sine of angle A is the sine of 135 degrees. So I get that C is equal to 15 sine 10.6 degrees divided by sine 135 degrees. So side C is approximately, do this on your calculator, you get 15 times sine 10.6 equals divided by sine 135, and you get that that C is 3.9 approximately. So C is approximately 3.9 units. At the end of a problem, it's nice if you summarize your work. So we can say, therefore, angle B is approximately 34.4 degrees. Angle C is approximately 10.6 degrees. And side C is approximately 3.9 units.